Okay, now let's see about the next topic, that is error checking. And here we will first do the first kind of error checking, that is parity checks. Let's start our lecture. This is Unit 2 data transmission for IGCSE and O levels book. Let's start. Now, error detection methods, there are different error detection methods. What happens actually, what is basically error in data transmission? Our data can be corrupted, lost, or changed during data transmission. Computers cannot understand corrupted data. Therefore, error detection methods are really important. Uh, Now, why do we need error detection? Because error may occur due to electrical interference. What kind of errors? The kind of errors we have already discussed. They could be corrupted, it could be lost, or it could be changed during data transmission. Yeah, or there could be packet switching problem. There could be skewing in parallel transmission. What is skewing? Skewing is that some bits are uh, sent with a delay. So that is called as queuing. So corrupted data becomes unusable for computers. Error detection ensures data accuracy. What happens? That's the first error detection method, that is called parity checks. Of course, it has its limitations. So we will discuss how it works, and it is very important. But of course, every kind of checking method has some limitations. Let's see about what is parity checks. It is based on number of one bits. One extra bit is added. That is called a parity bit. It could be 0 or it could be 1, depending on the need. There are two types of it. Even parity, total ones must be even. Odd parity means the total number of ones must be odd. We will see the example, then we'll understand it more clearly. How parity works. Sender sets parity bit before sending data, and receiver recalculates the number of parity bits. And if parity changes, this means uh, error is detected. There are some limitations. We cannot detect all kind of errors with parity checks. If two bits change, error may not be detected. Cannot identify exact error location. So these are the two major limitations. And then how we do the parity check, then here I'm going to give you the example. Okay, just right now I'm just giving the example of the parity check. I'm not getting into the detail how is even parity created, how is odd parity created. It will just be given that it is just decided between the sender and the receiver what kind of parity they will be using. uh, Okay, now parity check adds an extra bit to ensure data follows even or odd parity rules. If the receiver detects an incorrect number of ones, it knows an error has occurred. Now suppose we have even parity between the sender and the receiver. So assume this is the data 101, 0001. These are 7 bits. So there are 3 ones in it. Suppose we are using even parity, then our parity bit should be what? 1, because if we add the parity bit 1, then as the agreed parity is even parity, or if we add the parity bit as 1, then total number of ones will become even. So this is how this will work. Now in the second example, suppose odd parity is agreed between the sender and the receiver, and the number of ones in the data are already in odd numbers. There are 3 ones. So our parity bit will be 0, because we have to count the number of ones if they are even or odd. In this case, number of ones should be odd to avoid error. So this is how we will add the parity bit as 0. We have added it to the end, and parity bit here is added to the end. This last one is the parity bit, and here this last 0 is the parity bit. Okay, this is a big example, so we will see which bit is a parity bit. This is our data 1101101. This is 7-bit data. So 1, 2, 3, 4, and 5. There are 5 basically. How many? There are 5 ones in it, but the parity agreed is even. So the our parity bit be 1 will be 1. That will be our 8th bit. So then we will have 6 bits, the 6 ones. So that will make our parity even. Now this here our even parity is agreed. there are four ones in it. Four ones, this means number of ones are already in even number, so our parity bit will be 0. And here we have 0, triple one, triple zero. Even parity is used. Even parity is decided between them. So in order to make the number of ones even, we will add one more one to the end. So this parity bit will be 1. Then here we have odd parity is agreed. Now odd parity is agreed, but their number of ones are even. So of course the uh, parity bit will be should be 1 here. So this was a mistake. And let's see in this next example. There are 1, 2, 3, and there are 5 ones. So and the odd parity is used. So here the parity bit will be 0 in this, because number of ones are what? Number of ones are already in even number, in odd number. Odd parity is agreed, so our parity bit will be 0. Here we have how many ones? We have already six uh, 6 ones. So the parity and even parity is used, so our parity bit will be uh, 0, because it is already using 6 ones. 6 is even number. And in the next odd parity, this is odd parity, and total number of bits is 7, so our parity bit will be 1 here. And now in the next there are three ones, and odd parity is agreed, so our parity bit will be 0, because number of ones are already in odd number, so the next parity bit will be adding, that will be 0. And odd parity is agreed, and here even parity is agreed. The number of ones are even or odd, so we will add the parity bit as 1, because number of ones should be even. So 3 ones, and this is the fourth one. So this forms it an even parity. There are seven bits that are odd, 7 bits here. So this is odd parity. So so our parity bit will be 0. Why? Because odd parity is used. The number of ones are already odd. Okay. Next activity. Which of the following received bytes indicate that an error has occurred after data transmission? Let's see where do we have the error in this. Let's say number of ones. These are 3 ones, and then there are 6. So this is basically 8-bit data. Last bit is basically our so the even parity is decided. The total number of ones are 6, so it is expected answer is even number of ones, so obviously there is no error in it. Now in the next look at this data, the last bit is our parity bit. How we know? Because this is an 8-bit data, 7 bits are already considered, and the last bit is a parity bit, so that is telling that this is an uh, even number, so there is no error. Let's see why there is error in the second one. And there are 5, number of ones are 5, parity type is even, so parity that is decided between them is even, and expected answer was even, but our result is but their number of ones are given is 5. So expected result is even, but it number of ones are, that is 5, that is odd. So if it is odd, then this means it is what, let's call it odd, and let's call it odd. 5 is also an odd number, we will write it. 6 is even number, 8 is even number, and let me rewrite it for you, just to and and now just look at this. This is our table byte. This is our data that has to be transferred. This is our parity type that is agreed between sender and receiver. And these are the number of ones that are present in the whole, including the whole data, including the parity bit. And what the answer we are expecting, that is even. So if the answer is even, means number of ones here are even, this means there is no error. If this even and this even matches, this means there is no error. Now this is an even parity is agreed, but the number of ones are odd, and the expected result is obviously even. This is the basically expected result, so obviously error is there. Now this is another even parity is agreed. Number of ones are odd, and this means parity bit it has added is 0, and the expected answer is even. So error is, of course, there is an error. Next, there are odd number of ones. Parity type is agreed is odd, expected is odd. So and this number of ones are odd. So this is why there is no error. And then again there are 6 number of ones, but even parity is expected, and odd parity is expected, but our result is even, so there is an error. There are 8 number of ones. 8 ones means expected result is odd, but what we are getting is even, so this is an error. Number of ones are 0, again even is agreed, and so this there is no error because 0 is an even number and there are no ones. Next is a number of ones are odd, expected is odd, so our result is odd, that is why no error. Again, number of ones are even, expected is even, so there is no error. Again, number of ones are odd, expected is odd, of course 5 is odd, there is no error. Now in each case, this is the second question of this activity. In each case, where an error occurred, can you work out which bit was changed? We cannot identify which bit got changed during data transmission. It is impossible by using parity checking. Parity checking can only detect that an error has occurred. It cannot detect what error, where, which bit is removed or skewed or whatever. We cannot identify the position of the incorrect bit. It only works reliably for detecting single bit errors, but does not provide enough information to locate or correct the error. We cannot locate the position of the error, which bit changed, or we cannot do that. So for that, to improve that limitation, we come to the parity blocks.